The title of today's presentation maybe is not too good because the Shapeless is really, I cannot call it this huge library. This is a library, but let's say this is dense with many ideas which comes from the functional programming stuff, and I believe that for people who came to Scala from Haskell or such, this kind of languages is much easier to understand that stuff than for people in comparison to people who came to Scala from Java like me. Generally speaking, I'm Scala programmer, let's say, in an intensive way, some half of year. And previously, I just did one little project which was connected to my doctorate thesis. So how it looks like, what is the plan? The agenda is consists of just two simple bullets. The first one, I would like to show the problem we met and we wanted to solve it. And then we start the journey, yes, as a sailors, and maybe I just show you the option, and then I believe after this presentation maybe you will be willing to continue it your own. So about the problem. So generally speaking, we had, as the people coming from Java, we had to implement some REST service, and our imagination about that was that this has to be something similar to that what we have in Spring. And in Spring, or in Jersey, this is another library. And in Spring and in Jersey we have, let's say, two sections. The first one is a section which is saying us about the structure of URL. And in this section we can mark some parts of this URL which is then somehow mapped to the attributes of handler. And there are some problems, yes. The main problem is here that we do not have direct links between these two sections. So in any case, I will do some typo error in my URL. The request param won't be properly solved. Yes, and in some cases we won't be aware that there is this kind of error till runtime. Of course, that's what I'm saying right now. It is not fully true because we get a lot of libraries to guard, to be safe against this kind of errors. But this is just a beginning. So what we have here, we have some string. The string is somehow in artificial way mapped to the attributes. We do not have any junction in ties between that what we have defined in URL and that what we have defined in the handler. Pretty similar situation we noticed a few months later. We had in the Cucumber test, and in Cucumber test they decided to pass attributes to the, I don't know exactly how to call it, say the test handler or just a test, to data table. They are using such kind of ideas, and they have defined as some annotation like end or when or whatever else, and some group of regular expression when they are mapped to the attributes in the test. Yes, we are passing this manner, and it is done right now like it is. And guys in Cucumber have to deliver a kind of fix because in the library version for Scala 2.11 there was a bug. Yes, and we were, let's say, stopped to migrate to that version of Scala because of this bug, and we wanted to have our test also working. Yeah, and again, the problem is here that, okay, so I have some regular expression. This is just only letter expression, so this is alphabetic expression. This is numeric expression, so we have only digits. And there is a convention, okay, I expect here string, I expect here an integer, but of course we are not fully sure that in these cases, yes, in these cases we really get that what we are expecting in our test. The worst thing in this part, in comparison to that, is that here we have tests. Yes, we have test kits, usually delivered by I don't know, creators, authors of these frameworks. Here not. Yes, here is a place where we can do it better. And how we can do this better? Yeah. About tests I already said. About the libraries I said. About the tests we can do we can write some other, let's say, customized runners which are able to recognize this kind of situation, or we can just leave it to compiler. Yes, and this thing has been done by Spray. Yes, and it's Spray, and in fact we didn't implement our own solution. We just adopted that what was given us by Spray. And as a simple example of it, how it looks like. So, okay. This is a piece of my coding company. I hope this is not top secret and not classified stuff. The idea is here, what we have here. So the idea is that I have some function which gets some stuff here. Yeah. And I can write that as this is my URL. In fact, yes. This ready slide underscore means that we have applied in this place some implicit. I don't want to talk about that right now. But the idea is that I have defined this path, and in place of placeholders for my attributes, yeah, I put some special objects which are then somehow translated. Segment in this place means that I expect here a string. If I would expect here another segment, and I also expect here a string. So if I would like to get another stuff here, there is another version of this segment. This is called in segment. So in this place, when I put here in segment, means that I expect an integer. Yeah, and what is going on after that? So according to that URL, I can apply. Let me shift it a little bit. Yes. I can apply a function with signature which strictly corresponds to types I declared in this URL. So this retailer ID and promo version ID are just strings. If I put here another signature, yes, if I would mark this promotion version ID as an integer, I would get compilation error. And now I would like to show you how we can do something similar with Shapeless. Or maybe not in Shapeless. First we will talk about how we can do it ourselves using just the Scala. Let me leave it. So this is our entry point. Yeah, I would like to have some function with such kind of signature. The Scala is pretty fine language because it allows us doing some amazing things with types. And for me, as a man from Java, this does what amazing is that I could define some argument which of type S, and this type S I can then use to get a function of this type S. Yes, and what is nice, this can be compiled and is working. Also with unit I have stuff which is working, and the world will be really very nice. But unfortunately, in case of tuples, I mean the functions where we expect more than one argument, we do not have such nice stuff. It's because we are expecting in a natural way that we get a function with 2 or more arguments. The number will be exactly reflecting that what we have in the first bracket as a first argument. But is not done in this way because we get just a top tuple, which of course types in the tuples are correct. Yeah, but this is tuple. This is not exactly that what we want to expect. Why it is a little bit weird? And when we look at the functions, we have defined some functions for functions. And one of them is a function which is called tupled and if I'm sure, untupled. And these things are working only from functions of f2 and higher. So function 2 and higher have defined and working, but for function with one argument and a non-argument, empty argument list is not working. And this has some explanation because a tuple does not exist for tuple exists only for two or more sets, yes, as a product of these sets. In case when we have one set, tuple does not exist. Of course, it is not a problem for other languages. In Python, we have defined tuples also for one, and we have defined empty tuple and one element tuple. So it's not a problem. Let's say from the language point of view, this is rather a problem how we understand it. We want to understand this language. It's okay. We have this, and we would like to have get some signature like here, which is great. And fortunately, we have something which is called Shapeless, written by Miles Sabin, and I hope at least few of you were looking at his blog. Who read something from there? Great, one man. Oh, the second one, fine. A third, good. So we are a little bit, two more and we will be a crowd, yes? Okay. So the idea is that this guy wanted to implement many strange things which are, let's say, more characteristic for languages like Haskell, yes, and also wanted to check, for example, if our language, I mean Scala, is compliant with some, maybe now I'm wrong, but let's say is compliant with that what we can expect from the Curry-Howard isomorphism. Doesn't matter. And what he defined? He defined something, some being, some object, some class which is called hlist, and just hlist is just this is a list, but this is a list which is a tuple. Yeah, tuple and list in one. So we can do some operation on this hlist which are characterized for list. We can append something, we can prepend, we can reverse it. Many other things which are characterized for list, but not only. This list behaves like a tuple, so I can say exactly on what position I expect what type and how it looks like. So let me go back to, I don't know, I'm not too proficient in these tools, so every time I have to leave presentation mode. Okay, so this is how I can define a list, yes, with three elements list, where I expect on the first position integer, on the second string, and the third double. Yeah, pretty nice stuff. What is below, maybe we'll talk a little bit later, and let's say I don't want to dive into that right now because we are not the crowd who read these things. So, okay. So, explicitly writing these things, yeah, we expect that we have something like path h of hlist, and we put here that stuff which is in first parenthesis, and then we can get this function, yes, and convert it to function which is h-listed. This is pretty fine function, this guy, because it changed our function into function which gets a tuple. I mean h-list tuple, yes, not a normal tuple, but h-list tuple. And because of it, I can do, and let's say really next to the perfection, but of course it is more ugly it is uglier in my opinion from that what is written here. Yeah, anyway, but let's say this shows us where we are heading. So second approach. Second approach is that we don't have to call on the tuple, we don't have to call directly the constructor, yes? Again, we have for the tuple also defined a function hlisted, yes, after this magic imports. And it means that this A here is some subtype of hlist. And this subtype is exactly integer h_nil, yes, if we would see how it looks like inside it. So I replace now my my constructor with these functions in both cases, and we are going further. So okay, the strength of Shapeless is based on implicits. Yes, so anytime conversions are done using implicits. Implicits are everywhere. And this can be irritating in some way, yes, especially for someone who is trying first to understand how implicit works, like me. but fortunately, I was able to define some implicits, which turns my tuple into hList and my function into function which gets my which in place of my arguments gets a hList argument, yes? So this conversion is written here. This is rat function, so I expect that I have a function with 2 arguments and I get an hlisted function. The wrong thing here in this code is that I didn't explicitly write the type. Yes, the type is here would be T1 double colon T2 double colon h_nil, and here a little bit higher. I have also some conversion from tuple to magic stuff, yes, to some object which I called convert1, which takes such parameters inside that. So I have here some get, some field for it, and I have this tuple converted to hList. Yeah, so my function looks like then, in this case, like this. Yeah, so I have an f, and I call f with double has been converted to, this tuple has been converted to hList. So this is my call, and my function looks like this. And as you can see, if I change anything here, this from something different than I expect. So I expect that will be integer and string. So whatever I put here different from these 2 things, it does not compile. So now we will think about how to replace this tuple with something more human readable. Yeah, and you see that I introduced something which is called convert1. And as you could see, or maybe I will show it again as just a short tangent. No, not. Okay, Control N. This is called like path directives. Oh, cool. Yeah, okay, so when you look at the signature, which is done by spray, yes, it also, that's one nice slash convention. It is not directly said that we have a slash, we have some object here which is doing it for us. Saying more this is object and some implicit defined for this stuff. So this stuff is recognizing that, okay, I have a string, then I put a slash, so I should convert the string to this kind of object, to this path matcher. This path matcher is parameterized by something which is derived from hList, yes, and then with this object, I can apply appropriate another object directive, yes, which is my function. So here I have a function which is then also converted in something else, and so on. The idea is that in this place, yes, I'm using a kind of object. This is called in Scala, probably, maybe some of you heard about that. This is magnet pattern. Some people don't like it. Some other like it. And there is this discussion. These what are, let's say, on the dark side. So all grouches. Yes, they are saying that unfortunately, and when I'm using a magnet, I don't see exactly what kind of objects are converted to this magnet. So this is not seen. You have to look into some implicit object and see, and then figure out what types can be converted to that magnet. So we want to do something similar to that. Okay, so we have the next experiment. Okay. And in next experiment we have an object which is called convert to A. This is a code name. Okay. And as you can see, yeah, I can right now see the string. Yeah, the string is converted to my object. Yeah, and this stuff that what is here, I mean, is added. To not lie, you guys. Okay, so I have from string, yes, and I get the string, and I then convert it into convert to a object, and I create some data, and okay, so I have some slash operator, and after this slash, returns me a new convert to a object, and then I can, let's say, add next and next objects of different types, yes, and all of these are then converted into H-list. The problem is, yeah, then in this case, when I'm trying to record all types in my argument, that finally I will get the H-list which types is integer string. And this is the reason why I can put here the function in order of arguments integer, and string. So this is a mirror, yes? This is not exactly what I wanted to achieve. This is something which I get, and now I would like to somehow fix it, yes? Maybe I will also show you this operator. Yeah. So pretty simple. I have just a next argument of type k, and then I create a new convert to a, just appending to data that value, yes? So you see it? Follow me?
Or it's prepend.
Okay, cool.
I mean append is.
Okay, so how we can fix it? This is probably known by you. We can change a little bit that operator from appender to prepender, or different from appender to prepender. Okay. And then I will get another conversion. So I see, as you can see here, a little higher. Yeah, so now this guy is converted, and in fact everything is done in reverse order. So this one is at the end, but encode is in the head. yes, and now signature of function reflect that what I write here. And one thing I didn't mention right now is how I convert this function. Yeah? I do not use this, as you maybe notice, or maybe not, I hope yes, that function now is not limited only to two attributes. Yes, I can put everything what I can. And this stuff written here, yeah, allows me to convert anything, yeah, any type, to type where I have a t, which t extends hlist, and some type error, which is returned by my function. This trick with this implicit converter, yeah, I don't know how to say exactly with this object, is something which has been given by Miles Sabin in one of the examples, how to convert functions, yes. And as you can see, simple one line, and I can do whatever I want. So I can get here an empty argument list in the first section. I can get one, and I can, as many as I can, no more than 22, or maybe, I'm not sure if there is a newer version of Shapeless which extends this tuple size. Now is a 22. 22 is a magic number, so remember that. Many things it is. So okay, so we have it, but let's say we are not satisfied with this solution. In many times we could say this is good enough, but not for us. So before we will continue our journey, this is the stuff which shows us how implicit works more or less. So here I have a class which is parameterized by t, yeah, and I just want to create another class, another function where I'm using some implicit which is connected to this class. The easiest way is just to create some function where the type t is in context bound of this type A, yes? This is difficult to explain for me, I don't know exactly about that, but contexts are when you will start to study the church calculus with types, you will then recognize that they are context, and some types appears in some context of another types. And I believe this idea is taken from there. But that what I write here, it means that implicitly there is an assumption that I can replace the stuff with some implicit where I have some, what is that, EV? Evidence, yes, whereas some object which is called usually evidence of type of A parameterized by T, yeah. So this is just some shortcut for this writing, and when I define this function and I try to define this function defined in this way, which is great, yes, grayed out. So this doesn't compile. Why? Because the implicit is required in this place, and this guy will try to compile it, try to find some implicit objects A, which is parameterized by this K. But K is not the type in this place. Yes, it is just a place for type. Yeah, this is something. This is just a generic. So because that object does not exist, so we will get a compiling error. Yeah. Another thing, how I can define here only a kind of function foo, yeah, where such object already exists. So when I choose a string here, I can define it because here is defined some special objects, some special instance of this class A, which is parameterized by the string. Yes, this is the reason why in this place I can compile it, in this not. So how we can change it? Yes, we can solve it just giving to our function as an implicit some object B. Yes, so this is this evidence of type A parameterized by K. And then I can call it, but of course it is not a call. Yes, here is also this implicit. So this is a kind of carrying. Yeah, right. Okay. So and when I have write it this way, yes, and then also can call this function as a test, and everything is solved, yeah. So this is the reason why the implicits are not willing, unwillingly seen in place when we have some attributes, yes. There we have an implicit, and for example, we want to have here something else, yes. And in this case, that something else let's say the chain of invocation, I don't know, evaluation, let's call it. Yeah, because then we will get an information that compilator is not able to match list of arguments. Oh man. Okay. I know this is difficult. I spent few days to understand the stuff, and we are disconnected, but fast fix for it is probably unplug and plug. Great. So we know that, and okay, these are things I don't want to show you. This stuff is I want to show. So how we could write this function in another manner? This is what we have in the spray, what I showed you a few minutes ago. So instead of defining a function which gets a second section where the second argument where it's a function, I return a special object. Yeah? And this special object is called handle. I like handle because it defines only a function which gets my function here. Yeah? And I see that my object is parameterized by t, which is directly he, so there is no conversion here. Why it is used like this? Because Scala gives us wonderful stuff, wonderful syntactic sugar for apply methods, yes, and we can call it without this name. And when we use it, so what do I have? I have my path, yeah, and I can then invoke directly the apply, yes, in this place, without writing dot apply and that stuff. This is probably known by you and probably used because this is nice, looks really bright and robust, and every of us is satisfied with it. What we have here, this is my implicit digression is connected to this stuff. So what we have here, as we remember, these are recording as, let's say, these types or these objects of particular types in reverted order. So we have string 5 is string integer and string types, yes, and this guy is reverting it. How this is done? Just simple function, yes. I have a function where I try to append the k, yes, and fortunately in Shapeless we have some implicit which is this type, yeah. It's reverse of k of type this k and t. So k, t, and these things are also, as you can see, this is a subtype of h-list, yeah. So before I add the last let's say part of my URL, yeah, I just append it and I reverse it. Yes, this implicit is used by this reverse. Probably some of you will ask me why I cannot do this usually. So before every adding, I will do some reverse and reverse and reverse. Yes, and I don't need that special operator. And the reason is simple, because I'm not able to say Shapeless what are here these kinds, yes, these types. I'm not able to say it because in place when I define it, I will need another implicit, but not the type some kt and so on. These types are more complex. They are, and it looks like reverse of this stuff. When I reverse again, I will get the type reverse of this type. And what is worse in this place, in this case, is that when the output is not reverse and so on, the output is just an out, which is how to say it, undetermined or undefined, something like that, yeah? So this is the reason I can do this at the very end. Yeah, if I would do it earlier, I will get such kind of monster. Yes, class experiment. Yeah, this is. Oh, okay. So this is what I get. Yeah, I have to use this apply, and this apply is used only to apply implicit, which is able to convert this reverse of k, t, and other things to the concrete type, and then in place of out, the out also is somehow determined in this place. Yeah. So instead of writing such things, for me would better just to create another operator which I ends my URL. Of course, this is ugly, and we can solve it in a better way. And solution is pretty straightforward. So instead of appender, I will use prepender. Yeah. So again, I define my slash operator, and I'm using implicitly this prepender, which is also defined in the Shapeless library. And this gives me this operator. As you can see, there are 3 columns. Yeah, triple column. And this builds for me exactly what I want. So I have appender at the end of my list. The stuff which I try to append is at the end of my list. So then, yeah, then my function is now pretty nice. Yes, so I have correct order, and I have a function which signature of types of arguments is in correct order, and that's it. Yes, this is exactly what I wanted to achieve. Also, this working for empty, for one, whatever we want. Here is an example which does not compile because on the first position I have integer, but my path expect here to have a string, so this does not compile. And the question is, we are almost at the end. The question is why we are doing such complex things, yes? Where we are heading, what for it is. The world without types was so simple, so nice, bright, understandable, whatever we can call it, yes? Problem is that some crazy people, they are trying to do this from, I don't know, 60 years, and now they are feeling that this is their moment because we have enough powerful machines for this stuff. So they want to write the programs where they okay, this is visible. This is does not have to be in details. Yeah, they want to write a program which we can say about them that they are correct in compile time. What does it mean correct? It means that we know that let's say that the stop condition is well defined, and we know exactly that our program will stop. Yeah, and from what is this idea? This is idea which comes from the lambda calculus, from the church calculus, where we add also types. Because there is, of course, wise people are saying that this isomorphism, I will tell only that there are some let's say some links, yes, some similarities, yes, something which are things are really very similar, yes, in understanding between operation on types and operation on the logical propositions. So when we define here is just a definition of some logical propositions, and we have, this is pretty simple in understanding. It stands for that when A is and B is, then I can define the AND operation, which also holds. Yes, and in other direction. So this is something which introduced me operation on some logic variables, and I have here operation which is saying me how I can use it. So when A and B holds, it means that A holds, yes? And I have another operation when A and B holds and B holds as well, yeah? And here is just an implication. So when like let's say we would write here arrow, yeah? A implies B, yes? And A holds in this expression, B holds as well. Yeah, so this is simple rules, and we can write it. We can prove that they are correct. We can prove that there is no place for, let's say, saying that we are not able to say if this rule if this rule holds or not. Yeah. So if our logical stuff, our logical expressions are correct and are well defined, we know that we have, when we will run on it a machine, some Turing machine or something like that, we then know that our program will finish in infinite number of steps. And here is, of course, what I said about the lambda calculus. Yes, the things looks really very similar. And in fact, there is an isomorphism between these two things, yes? So when we have something which is defined in something which is called this is difficult for me in English to pronounce every of these words. Let's say natural logic, yes? There is a counterpart in lambda calculus with types when we can use these rules, and then we can prove that our program is correct. So, okay, my long speech is just to show this guy. I'm not sure if this is not so easy. Yeah, for me, let's say the most important stuff is this. Yes, the proof if my logical expressions are correct means that my type system is able to solve. So everywhere I use my type, I know that I get correct stuff. Of course, there is some jeopardy in this place because my type system can be wide enough. Let's say that from some point of view can be seen as let's say expression without types. Yes, in this case we are not able to say then if a program stops or not, especially when we have recursive calls. And this is the last thing, let's say, I want to show you, or share with you. How this guy looks in Scala. So it's not a shapeless, but close to shapeless, and in the spirit of shapeless. So these things were defined by Konrad knows him, Stefan Zeiger, during Scala IO in Paris. He presents some paper about type operation on types and how to replace functions by types. So instead of writing such things, yes, so I define two functions here, some AND and some OR. Yeah, I can convert it into something like that. Yeah, what for? For this. Yes, I just compile it yes, and my program is saying me here, okay, I can solve my type system, so okay, my program is correct. So I don't need to run the runtime test. This is compiling is saying that when compilator says me that everything is fine, from my perspective, my program is also fine. Great, yeah. In this place I want to stop here, not showing more. As some curiosity, I can tell you that in Shapeless we have also defined natural numbers. Let's say in a way how it is done by, this is called piano numbers. Piano numbers. I don't know, piano numbers, piano, something like that. So in lambda calculus it is like S of 0, S of 0, and so on. So this defined, and probably first 22 are also defined and available. More you have to define it yourself. And these numbers can be also used as arguments into your functions, yes. And you expect here exactly 3, 5, and 6, yes. Whatever else you try to put into your function means that this is the wrong type. And at the end, if you really feel good with this stuff and feel that this is interesting, you can try to do some exercise. And this exercise is connected to this problem. Yeah, so this is Cola's problem. Doesn't matter what it is. There is no proof, yes, that this program will stop. Now it will stop for all checked numbers, but we can write in Scala, for example, using some type system. So we will define a type system to try, let's say, to prove that, let's say, in some range, yes, our type system is solved in correct way. So I know exactly what I expect in next recursive call. This is recursion, as you can see. Yes, if number is even, I just divide it by 2, and if odd, I multiply it by 3 and add 1. Such steps. And simple program, but probably in type, if let's say we limit n to 100, then we can construct a strict type system which tells us during compile time, yes, that whatever I put into my program from 1 to 100, it will compile and compile later tell me that my type system is solved correctly, then I don't need any test for it. And that's it. Any questions?
Yeah.
Yeah, come on.
What if you pass a null value on the function that you did? It should compile but crash on runtime.
Null value?
Yeah.
I don't know. In Scala we don't use null. To be honest, really, I don't try it. Yeah, I didn't try it. But generally, I'm avoid. This is something yuck, and I really don't use it.
But by not having, as I understand, by not having fully, dependent types, meaning you can't get a type out of a normal natural number, you need to encode all numbers as types.
Probably,
using
yes.
this lambda calculus-like method, right?
Yes.
So this is very convenient. So
yes, very convenient. This is because this is why I call it curiosity, because I don't believe it will come to let's say, I don't like this word, enterprise coding. Yes, it is rather for guys, from academic people, but from our perspective, on me, yeah, I'm just coding some enterprise code. This is something which, let's say, make wider my mindset. Yes, that this is also possible.
Yeah, but there are practical things, like, I guess, to be used with fully dependent types, like modular arithmetic, or you can have a type describing what's the modulus of.
Yeah, you're right. If the set is small, you can code every of them as a separate type. To be honest, in Stefan's presentation was also some junction. I mean, the function which were controlled somehow by types and by parameters. Unfortunately, I didn't read it deeply. I don't understand it yet. Yes, maybe there will be someday when I say, oh yeah, great, I understand that. But also there are some works. Yeah, let's say, as you said, yes, this is hard to define type for in fact any potential instance. Yeah, but we can, let's say, go for we can go and we can agree for some kind of consensus between these things. Yes. For enumeration, enumerations are in fact types, yes, anyway, for example, in some numbers.
So have you tried to solve this exercise?
No, it's not for me. Okay, I cannot say about myself that I'm not the man of the knowledge. I'm a little bit the man of the knowledge, but that's. Let's say I have a little wider spectrum of interests, so it's not only type theory and algorithm, maybe some things like that, and we'll find some time, maybe, yeah, will be good as an exercise. Okay, cool. Thanks guys for coming here.